Hey guys, welcome back to OTI Institute, and today we are going to go over Chapter 2 of AP Calculus AB. Okay, so the Chapter 2 is about limits still, and we're going to go over some two important limits. We're going to go over squeeze theorem, and we are going to go over a lot of stuff, and yeah, and we're going to do some practice questions at the end as you see right here, okay? So, starting off with the two important limits, we have the squeeze theorem, the part one of the two important limits. So what is squeeze theorem? So it's basically like a sandwich, I would say. So if you look at this graph right here, let me box that up, okay? Let me box this up. So if we look at that, okay, we see that fx and gx in the middle. So first of all, that is wrong. I'm gonna label this as fx and label it as gx. Okay, so you see this fx now between the gx and hx, and it's like sandwiched between the two other graphs. Okay, so here in squeeze statement, it's squeeze theorem. It states that it's used to find the limit of a function that is trapped between two other functions whose limits are known and equal. So that this is the theorem. Okay, so the theorem is if gx is smaller than fx is smaller than hx for all x in the open interval containing c, expect possibly at c itself, and if limit x approaches c, gx equals to l equals to limit x approaches c, hx, then the limit of fx as it approaches c must also be l. So here, and it shows right here that the limit x approaches c, fx is also l. So basically what it's saying here is that if these two are the same, equal to a number l, then this must also be equal to number l. We can see it right here. As x approaches c, the squeeze theorem, this approaches l. This point, they're all l. They're all the same as x approaches c. Okay, so that's basically what the squeeze theorem is trying to say right here. But this honestly isn't really tested a lot. Isn't tested a lot. Okay, I just want to say this right here. So we don't really want to take too long on this theorem. So we're gonna move on to the next theorem about the two important limits. Okay, so first, here the two important limits are actually first of all, these are some examples of squeeze theorems, and you can go home and do these, but right now we're not going to talk about them because squeeze theorem isn't that essential in AP Calculus AB as I just stated. So the two important limits right here. So the first important limit is actually limit of x approaches 0 sine x over x equals to 1. Okay, so this is actually proved by the L'Hospital rule. Proved by L'Hospital's rule. Okay, so yeah, so this is that limit right here. So we are gonna go over L'Hospital rules in our derivative unit. It's basically something like this. OG. That this is like the L'Hospital rules, but we are gonna go over this in our derivatives unit, but not now. So right now we're gonna focus on this limit. So as limit x approaches 0, sine x over x equals to 1. Okay, so here I just want to give you just need to memorize this, not that important, but like here I will give you an example question. So I should here find limit of x approaches 0 sine 3x over x. So sine 3x over x is basically first of all, we can actually multiply both sides by 3. As you see here, we multiply both sides by 3. Okay, and then we take that 3 out, and then so because we want to get that 3x as 3x approaches 0, because okay, so let me make this clear. Okay, so our main goal right here is to make 3x approaches 0. Why? It's because these two are all 3x. So we want to make 3x equals to u as a substitution. So we make 3x equals to u, it'll be a lim of u approaches 0 sine u over u. And this is basically that theorem right here, okay? These two are related, and this should be equal to 1, okay? So since 3x equals to u, then x equals to 3 because u equals to 1, right? So x equals to 3. So that's our answer. But so that's why we originally here we were trying to like um multiply 3 on both sides so we can bring that whole 3 out of the limit function so we can make it 3x approaches 0 and then sine 3x over 3x. So this is the essential of what this part actually means here. Okay, so moving on after the first limit, we are gonna talk about uh, another part, which is the second important limit. And the second important limit, we are gonna talk about this in our next class.